Hi, this week we were talking about the transformations of logarithmic functions. And we're going to be talking about the ones non-natural for the first ones, and we'll talk about the natural ones on the next lesson. So let's talk about what that means. With these, we're not going to be focused in on exactly how do logarithms work. We're going to focus in on that later. But for right now, what's important to know is these are the inverse. They undo an exponential function. The base here tells us our number. So this is log base 2 of x. This is the inverse of y equals 2 to the x. What inverse means is it can undo the function, and what this means for graphically, it means it can be folded across the line y equals x. And so if it was affecting the y's last time, it's going to affect the part is going to be with the x value. So if we were looking at consistently the y-intercept, we're now going to be looking at the x-intercept. If it had a horizontal asymptote, now we're going to talk about a vertical asymptote. And those are the key features that we are going to be looking at that are different. And so our asymptotes each time this week are going to be focused in on x equals whatever it is. And so when it is in the parent function state, which means is it at the starting point, it's going to be x equals 0. Our x-intercept is where it crosses the x-axis, and that is going to start off at 0, 1. Our domain is going to fluctuate like our range did last time. It is going to always start at your asymptote and go to positive infinity. One nice thing on this is we are not going to be dealing with any that reflect over the y-axis. So this number will match, and it will always go to positive infinity. Your range will be consistently from negative infinity to positive infinity. This is one of those functions where I told you at the beginning of the year the domain is not all reals. This is one of the ones that we're going to be dealing with that has a restricted domain, meaning not all x values will be able to be plugged in. And so keep this in mind. Our domain is restricted on this one compared to last time. So if we have the parent function log base 2 of x, and we change it to 1/3 log base 2 of x. So just like we had in the exponentials, when there was a number in front, it dealt with a stretch or compression. This time, being less than 1, it's going to be a compression. And so as you see here, the purple line has been compressed vertically in. Oops, and I've had some numbers here already up here. So our asymptote is x equals 0. That's from the standard. We didn't move it left and right any, so our x-intercept is 1, 0. Our domain is going to start at whatever value this is, so 0, positive infinity. And your range is consistently negative infinity to positive infinity. This does not change the entire way through our logarithmic functions. So we'll have that same range every single time consistently. So if I had a negative in front of my logarithm, that's going to reflect it across the x-axis just like it did last time. So, and this has a 3, so that means it's a stretch. So our asymptote still is x equals 0, because that's the line here that we're not going below. The x-intercept, we're still going through that same spot, 1, 0. Our domain starts at our asymptote and goes to positive infinity. Our range is consistently negative infinity to positive infinity. So just summing up, the transformations that we have when we have a in front, if it's a stretch, a is greater than 1. It's a compression, And these are talking about vertical if it's between 0 and 1. And it is reflected if it is less than 0. And again, these are talking about like the absolute value of this. So you could have a multiple thing. You could be reflected and stretched, or reflected and compressed. What do you think is going to happen when we add 6 to the end of it? If you answered moved up 6 units, you are correct. So is it going to affect our asymptote? Well, we aren't changing away. We aren't moving left and right any, so our asymptote is still x equals 0. But our x-intercept is going to be harder to find. We are going to have to type in and get the calculator to help us find our x-intercept. Our x-intercept is when we have a 0 for y. And I am going to omit any questions we're asked you for finding the x-intercept right now because we have not discussed those. Or if that part is on the question, I will not count that against you. So there'll be some curve on this Pearson assignment. So anything that's asking for an x-intercept when there has been a vertical shift, unless it's asking for a decimal that you can use the calculator for, I will omit. So if it's asking for exact values here on x-intercept, I will omit it if it is a vertical shift. Our domain is going to go from 0 to positive infinity. Our range is negative infinity to positive infinity. And I forgot to put the decimal of what that is on my computer, so we're going to skip x-intercept on this one. But you would just find the calculator. If it was one that you could actually round, you would just use the decimal off the computer. And like I said, unless it's not, only time I'll make you do x-intercept is if you can do it with a decimal on this lesson. So if it's positive, it's going to move it up. And if it's negative, it's going to move it down. It is going to change x-intercept. And that is it on the functions of what it's going to change and those key features. Now, let's look at what's going to happen if we have it inside the parenthesis, log base 2 of x minus 4. So that means we are going to either move it left or right, and just like we've always done, it's going to go opposite inside. And so that's going to change our asymptote. It's going to change our domain. It's going to change our x-intercept. This one we'll be able to find exactly, and so you have to do the x-intercepts on these. Only reason we didn't on the last one is because there won't be exact values. And so this one, we need to shift it over to the right 4 units. And so our asymptote is x equals 4 now, because we want 0 plus 4. Our x-intercept was at 1, is now at 5. Our domain is going to start at our asymptote, so 4, comma, positive infinity. And our range stays the same. So, if it's positive inside, if you're adding, it's going to go left. If it's a minus, you're going to go right. This is going to change your domain, your x-intercept, and your asymptote. Thank you for listening to this, and let me know if you have any questions. Remember, you can always email me or talk to me that way.